Okay, we're just going to do a quick application of Mohr's circular stress, and very specifically for the plane stress element. So we have a plane stress element shown here in its XY orientation. It has an 81 megapascal compression on the X face or the horizontal or the vertical face, a 129 megapascal tensile stress on the horizontal face or the Y face, and a 36 megapascal XY shear stress. And so what the question asks us then is is to draw the Mohr's circle of stress diagram for the plane stress element, and then to identify on that diagram the maximum, minimum, or principal normal stresses, the average normal stress, the maximum shear stress, and to identify approximately what the angle of rotation is to the the orientation that the principal stresses occur. So we're going to do it. So I've already drawn out an axis that will accommodate what we need. And we're just going to step through this rather methodically. So the first point that we have to plot is the vertical face. And so it's at negative 81 normal stress and negative 36 for shear stress. So we're just going to find that point here, and that should be our vertical face, and I'll identify the coordinates. So it's negative 81, negative 36. Note that the shear stress is positive down for the creation of the Mohr circle. And then I'm going to plot the horizontal face, which is at positive 129 and negative 36, but in this case we actually do the negative tau xy, so we're going to be plotting it at positive 129, positive 36. And right about here we should have the horizontal face, and plot coordinates for that, as we mentioned, were 129, 36. Now, what that allows us to do is we can actually connect these points and they will pass through the average stress where shear stress is equal to 0. So I'll just grab a straight line and we're going to connect them. So we may as well calculate the average stress. So we've shown stress average here, and of course that's equal to sigma x plus sigma y all over 2, which is equal to negative 81 plus 129 over 2, and equal to a value of 24, which means our diagram is pretty much to scale. So that's great. So now what I want to do is I'm actually going to connect this with the circle. So the stress average point at tau xy equals 0 is the center of the circle, and the horizontal and vertical faces are on the circumference of the circle. So we should be able to plot a circle. So I'll just plot the circle in there, and just so we can use the number, the radius of the circle we know is equal to the square root of the sigma x minus sigma y over 2 all squared plus tau xy squared. And in this case, that's going to be equal to a value of 121. So now we can mark some critical points that we might want to have. So the first one is if we draw a vertical line up to the top, and we see this is where our maximum tau max occurs, and that's going to be equal to 121. Now we can mark our principal stresses. So the principal stresses occur at the extremities where shear stress is equal to 0. So we just go down along the x-axis and we can mark these points. This is going to be sigma max And that's equal to about 145. So that's just the radius plus the average. And sigma min on this side is equal to minus 84 at that point right there. And that's our two principal stresses, which leaves us the last question, which was what is the angle at which the principal plane occurs? And so that angle, if I were to show it graphically, is the rotation through here from where the vertical face rotates around to be the sigma max. So that is 2 theta p. And I'm just going to use it graphically and say that that's about 180, call it 200 degrees. So theta p is approximately equal to 100 degrees rotation. And that's certainly, there's a lot you can do with Mohr circle. It's a great representation. Up until now, we've focused primarily on the equations for rotational stresses and principal stresses and everything else. But this is how they manifest themselves when plotted graphically. So hopefully very effective in allowing you to visualize how the components of stress vary as your orientation in the element rotates. Hope that was useful.